Hello everyone, my name is Praveen and I welcome you all to your own YouTube channel Java Fun. This is the fourth lecture is in the fault tolerance microservices series, and in the first three lectures we talked about what exactly is a fault tolerant, what is circuit breaker, how to implement circuit breaker using plain Java, and the integration of circuit breaker or the implementation of a circuit breaker using Resilience4J library and its integration with Spring Boot. So the next strategy for fault tolerance microservices is something called as bulkhead. And the bulkhead pattern or the bulkhead is a convention which has been coming from a shipbuilding industry. So bulkhead is nothing but compartments which has been created inside a ship. So the idea behind that is if at all your ship has any sort of particular problem and the water gets leaked in within the ship, it should only be filling one particular compartment, and it should not affect the stability of your entire ship. So it is basically isolating the certain sections of your ship from the other sections altogether. So the failure or the damage in one particular compartment should not affect the architecture of a ship. Now, what does that has to do with softwares or the microservices, right? Uh, so in microservices as well, you have different components which has been coming into picture, right? When you are working on any or when you created any particular functionality. So in our earlier lectures, we have seen an example of an inventory and the order service. So we have basically saw how service A is interacting with service B, and how the threads are created with every HTTP request, right? Now, what if in this particular scenario, your any particular service has any particular problem? So if service B goes down, or the this particular instance of service B goes down, or this particular instance becomes slow for a certain reason, right? And it will keep on piling up the request on the service A side, because the service A threads will be waiting for that thing while the response from service B. And now, as and when it tries to serve the traffic, its cascading effect will be on its upstream systems as well. So any particular problem within your microservices architecture, it is having a ripple effect on the other thing. So how do we compartmentalize this particular thing? So suppose this is not service B and suppose this is service C, right? Now service C is perfectly fine, service B is having a problem. Now because of service B, service C functionality or the functionality served by service C also going to get affected, because these threads will keep on accumulating. Any new request which has been coming in for functionality served by service C, the threads will not be available for it. So what we need to do, we need to compartmentalize each instance or each functionality served by service B. So this is what has been depicted into this particular diagram, right? So we will compartmentalize this thing so that if this goes down, let it go down, we don't care. And suppose this is service C. Now the compartment served by service C functionality should work as is. It should not have any effect onto the uh, functionality served by service C. So this is basically a layman idea of what exactly is a bulkhead, right? So how can we implement this thing in the microservices? Now, if you have worked on Hystrix library, Hystrix also provide us a bulkhead, or provide us an implementation of a bulkhead pattern, as well as a circuit breaker, right? So in this particular series, we are not looking at the Hystrix, but we are looking at the Resilience4J. So with Resilience4J, it is basically a superset of Hystrix, as you can think about it. It is giving us two implementations of bulkhead. One is a semaphore based bulkhead, and another is thread pull, fixed thread pull bulkhead. So we're going to see the both the patterns, how we're going to implement it. It's basically very simple. So unlike Hystrix, if you see here, unlike Hystrix, which does not provide a thread pull option, Resilience4J does provide you a thread pull option. So we're going to see how the semaphore based bulkhead works, how the fixed thread pool bulkhead works. Now, as we see, we are compartmentalizing our microservices. What we need to do is we need to limit the number of concurrent calls which has been made to a particular compartment, the number of operations to a particular compartment. So the number of operations should not exceed any particular number, and so that we can preserve the resources, the limited number of resources which has been available, or we can divide the resources between the moving parts that we have in our microservices architecture, right? So uh, this two services I have, one is your inventory service and another one is your order service, right? So very simple, I have one controller called as order controller. Here, before placing an inventory order, so inventory can be anything, it can be soap, biscuits, grocery items, whatever, right? So we have discussed this thing in our earlier lecture, so I'm not going to repeat the same thing again. So we are getting a request to place order. So what this particular endpoint doing is, it is basically checking with the inventory controller if a particular inventory and the number of units of inventory is available or not. It is giving you a boolean result back saying that if it is available, it return you true. If it is not available, it is just return you false, right? And if I am receiving a result back which is a true result, then I'm saying that order placed successfully. Okay, and if I don't, then I say, so this is ordered placed successfully. If I don't, I would say order failed, right? I'll put a small sys out here as well. Okay, pretty simple, nothing complex into it. So the another service that we have is inventory service, wherein we have an inventory controller. Here we are checking if I'm getting a soap as a unit and the inventory size is less than 10, then I'm just returning true. If it is rice, inventory size is less than 10, I'm returning true, or else I'm just throwing an internal server error, right? Pretty simple. Now we use the same example in case of circuit breaker. We're going to use a similar example in case of bulkhead as well. So I'll go to my application.yaml. So this is my circuit breaker configuration, right? So for bulkhead configuration, I say bulkhead instances similar to what we are doing it here. Then the name of my bulkhead instance is bulkhead inventory bulkhead, let's say. Now we give a, this is inventory bulkhead, and now we give a configuration for this particular bulkhead. Now let's say max wait duration. So what we are seeing here is if the limit has been breached for number of concurrent calls which has been allowed, right? So how much time it needs to wait. So let's say max number of concurrent calls that we can allow. Let's say I allow only 3 concurrent calls. Wait duration, if the limit is been breached, how much time we need to wait before it can be retried again. So let's say 10 seconds, it's in milliseconds. Okay, and event consumer buffer size is something wherein it keeps on emitting an event, right? So you'll create some kind of a buffer to store those events. So what is the, we are not added any listener for those events, uh, so it's optional, you can give or you can just omit it. So I'll just put some number here. Okay, so once you have the configuration in place, we'll go back to our main service or our main controller, and the way we have added a circuit breaker pattern annotations, right? We'll add the bulkhead annotations as well. So I'll put bulkhead annotation. It has two parameters similar to circuit breaker. One is name and another is a fallback method, right? So what I will do is I'll use the same fallback method that we used in circuit breaker one, and the name of my bulkhead is inventory bulkhead. I'll put the name here. Okay, so what we are doing, we are basically receiving an inventory order, and we'll making that inventory check to the inventory service. If we get a boolean true result back, we'll say that order has been placed. If not, we say that order has been failed. So let me say order failed. I just added a sys out here. On the main class, what I'm doing is I'm making 20 calls once my service has been coming. Once the service is up, I am making 20 calls, which is parallel calls, the concurrent calls, because I wanted to check the concurrency with the bulkhead one, right? So I'm making a parallel calls, 20 parallel calls, and according to our app configuration, only 3 concurrent calls has been allowed. So if you are receiving more than 3 calls at any given point of time, they have to wait. Our wait duration is 10 seconds, and during that duration, after that duration, it will keep on retrying those calls, right? So that is what we are doing. On our other service side, what we have, so as of now I just comment out this thing. We receive a call, we'll check if it is inventory soap units is less than 10, we'll just return true. Rice less than 10 units, return true. Otherwise we just throw an internal server exception, okay, because that's not in the available in the inventory. So I'll start this service as of now. Once this service is up, we'll start our order service as well, and then we'll see what is the behavior, right? If in the absence of bulkhead, all the calls should be successful. So let's test that once first. Okay, so I'll go to my order controller. I'll comment out the bulkhead. So this is our normal behavior, right? So let me run this. This service is up. Let me run the order service. So at this point of time, no call should fail. Everything should be successful. So let's verify that. And another thing is, in case of fallback, it will just go to fallback method and just printing it out that it is inside the fallback, right? Okay, now it will make a parallel call. So everything should be successful, should not receive any exception. Yeah, everything is order placed successfully. Everything is order placed successfully. Everything worked. Now let's do another thing. Let's introduce a bulkhead configuration now. Now we'll see what is the behavior. Only 3 calls are allowed at any given point of time right now. We should not make more than 3 concurrent calls. So we should see a little bit of delay when these logs are getting printed. Okay, service coming up. Let's see. Should make a call now. Okay, even in this case, since there is no delay, we are getting the results back properly. Okay, now let's do one thing. It's very interesting. What we'll do is we'll introduce a delay into it. What we're going to do is, to start with, I'll introduce a 5-second delay. Okay, and then we'll see how the behavior is right now. Now we are deliberately delaying the response. Service is coming up. I'll restart our order service as well. Now max wait duration for our configuration is 10 seconds. So here also I should not see lot many failures, or maybe very little failure, because it is still under our max wait duration limit. But as and when the max wait duration keeps on increasing, it will keep on invoking the fallback methods. Okay, let's see what happens now. So it make 3 calls, it wait, it will receive a response. So it's, if you see here, at any given point of time, it is only making 3 calls, not more than 3. Okay, so this is how the bulkhead configuration coming into picture. Now still there are no failures, everything has been working perfectly fine. Now what if I increase the delay further? Now what I'll do is I'll introduce a 10-second delay for every call. Now I should fallback getting triggered, and the call should start it to fail. Okay, but still in this particular scenario you should only accept or make a 3 calls at any given point of time. And since with the semaphore based bulkhead pattern we are not queuing up the connections, it will immediately fall back onto or immediately go into the fallback method once your wait duration expires. There is no queuing up of these requests, and keep this thing in mind. So 3 calls made, it will wait for 10 seconds. Now if you see here this particular exception, bulkhead is full, does not permit further calls, and it goes inside the fallback, right? It goes inside the fallback. The requests are starting to fail now. Few requests are starting to fail, right? This is how your bulkhead coming into picture. Okay, the next thing that we need to see is how we can queue up this request, or in the other sense, how we can use a thread pool based bulkhead, right? So let me do this thing. I'll remove this semaphore based bulkhead configuration. What I will do is I'll put a thread pool bulkhead. Again, instance name is what we given, inventory bulkhead. Okay, now event consumer buffer size, again the same thing, that number of events. What kind of events? These kind of events. This is the event, the bulkhead is full, does not permit per calls. So since I told you already, your bulkhead and everything has been implemented by your internally, they have a state machine kind of an object, right, wherein they keep on emitting the events whenever the particular changes is happening within your circuit breaker or a bulkhead or a rate limiter, which you're going to see in the next lecture. And you can put a listener on top of it so that you can understand at what point of time bulkhead is getting full, circuit breaker is falling, fallback is getting called, and all those kind of things. So those events, how many events you can want to buffer at given point of time, I said 10. I'm not really putting a listener on top of it. Next thing is core thread pool size. What is the how many number of threads you want to create in your thread pool? So I'll say 5. What is the max? So at any given point of time the 5 threads will remain active. Max I said 7. So I want to keep the 7 threads into max. It can grow up to 7. Queue capacity, this is what we're discussing in our semaphore based one, right? So in the semaphore one there is no queue mentioned, so that moment your bulkhead is full, it will keep on falling back into the fallback method, right? But in this particular scenario, I can queue up certain certain calls, right? So my queue capacity, let's say 10. And keep alive duration is, if your thread is idle in your thread pool, how many seconds you want to queue it up before it can get removed from your thread pool, right? So only the core size will remain there, and whatever is an extra threads which has been created up to max thread pool size, right, those will be removed if they are not required. So I'll say wait for, let's say, 5 seconds. Okay, so I'll keep the same 10 seconds delay here. In our other service is already up, so we have 10-second delay. So when we run it last time with the semaphore based one, few of our calls has been failed, right? So two calls failed last time. So let's run with the thread pool based one, and let's see how it behaves this point of time, right? Let's see. So here, if you noticed in the last one, we have mentioned the max number of concurrent calls which has been allowed, right? So here there is no such property like that. There is no nothing called as concurrent calls, but your concurrent calls has been defined by your thread pool sizes, right? So how you configure your thread pool will define the concurrency level of your application. So at this point of time, I made like first 4 calls has been made, and it is waiting for the response. I got the response properly fine. Again 4 calls has been made, waiting for the response, got the response. No failure till now, even with the 10-second delay. Okay, we should have, yeah, I think all the calls has been made, all the calls made successfully, everything has been done. Okay, there's no failure. So as you can see here, because of introducing of this particular queue, we are seeing that it is scaling up pretty well, and we can have more control with this kind of a bulkhead pattern. Now what I can do is I'll introduce the number of, or I'll increase the number of calls that we are making. Let's say 100. So my concurrency level is still 5, or it can max go to 7, right? At any given point of time, I'm only queuing up 10 calls at my side. And let me do this thing now. Here I'll increase sleep time to, let's say, 15 seconds. Let's say 15 seconds. Now let's see what happens. I'll stop it, restart it again. And this particular pattern is very useful when you have a number of microservices involved into serving a particular operation, right? You have more than 2 3 microservices involved, and at that point of time it's very necessary to understand um, how you can put. So traditionally what we were doing is we used to put HTTP read timeout or HTTP connection timeout, right? But with this particular thing, you have a more fine grained control on top of it, and you don't need to code anything for it. It's just a more of a configuration thing. So what you can do is the delay and the failure in any particular service is not really having a ripple effect or the cascading failures on the entire microservices architecture that you are having. So this is a very important pattern in case of fault tolerance. Okay, so let's see what we're doing. Service is coming up, 15 seconds delay. And how many calls we are making? We are making 100 calls as of now concurrently. Let's see what happens. 4 calls made, 15 seconds. After 15 seconds you should see a response. At this point of time your queue must have been filled as of now, and the request must have been waiting. So threads are waiting, it's not falling back, but also you're not overwhelming the other service which is on the other side, right? You are only making a configured number of, the less than the configured number of calls at any given point of time. Still working perfectly fine, no failure as of now, still fine. So I'll let it run, right? And I assume that it should work perfectly fine. Okay, so this brings us an end to this particular lecture. If you have liked it, please go ahead and subscribe it to the channel. This is a motivation for a new YouTuber like me. It gives a motivation to come up with the new subjects and the new tutorials. So this was the fourth lecture in our fault tolerance microservices series. If you have any question regarding this particular lecture or any of the microservices based architecture questions, please put it in the comment. If you have any suggestions to improve the narration style, please put that one as well. I'm pretty much happy to answer all the questions which has been there. So as part of the next lecture, we're going to look at the rate limiter. So there is a subtle difference between concurrency and the rate limiter. So we're going to look at it in our next lecture. So please stay tuned and keep subscribing. Thanks so much.